Okay, so then for this evening's presentation, I'd like to welcome Ray King, one of our alumni at Harper here. And Ray's, well, he'll no doubt elaborate on his career journeys that he's been on sort of since he graduated from Harper. But we'd like to welcome him here as the lead engineer from the small robot company to give his presentation on Super Tom.
Yeah.
Okay, over to you, Ray.
Thanks very much. Yeah. So, yeah, my name's Ray. I graduated from Harper in 2012, which seems like a very long time ago. I suppose it is a very long time ago. Since then, I've worked in a number of different sectors. So, agriculture, construction, and I spent a bit of time working in aerospace as well. I've been working for the small robot company for roughly 2.5 years now. So in that time, as I'm hopefully going to show you, quite a lot has changed, and we've made some serious progress. Or I think we have anyway. So yeah, I'll move on to the next. So, there we go. So yeah, I just in this presentation just want to run through a little bit about small robot company and kind of a little bit of a history about kind of how small robot company came about, when it was started, and a little bit about the concept that we're kind of how we're approaching robotics in agriculture. Also want to run through what is Tom, because it's been a really big part of the work that we've been doing. And then the evolution of that, the concept of Tom, and also the design of Tom, and then go into a bit of detail about that, how we developed Super Tom version 3, which is the one that you can see here in this little animation, sort of our latest incarnation of what we call Super Tom. So I will go to the next slide. So yeah. Small Robot Company was founded in 2017 by co-founders Sam Watson-Jones and Ben Scott Robinson. Basically focused on harnessing the power of the precision of small robots, and the application of software and AI for the production of broadacre crops. We're kind of consider ourselves part of the fourth agricultural revolution. I'm sure everyone's got a lot of different ideas and opinions on that. But yeah, so that's kind of the angle we're coming from. I've got kind of took a nice, I took that directly from the website, the Feed the World, Regenerate the Planet. So there's a heavy focus on regenerative agriculture and trying to use robotics to help us to achieve that. Yeah, so I'll go on to next slide. So the concept that's kind of evolved and been put forward is kind of Tom, Dick, and Harry with Wilma. So Tom, Dick, and Harry are 3 different robots, or I personally kind of like to think of them as robotic functions. So things we can go out and do in the field with a robot, not necessarily a specific robot. So there's Tom, which is a scanning or a scouting robot. There's Dick, which is a weeding robot, and then there's Harry, which is the planting robot. So there's quite a nice video here. Hopefully you can see that. It's showing all right. So this kind of shows you a little bit of the concept of scanning, then the weeding, and then moves on to the planting. It was a sort of a proposed methodology at the time when this was created, to kind of have a modular system. We've kind of embraced that, but in a slightly different way. But the idea is that large numbers of parts from the robots we can chop and change them, but kind of between each of the functions. So, and then there's Wilma, which is the user interface, the planning, and the AI software. So I've got a bit of a video here. So this gives you a really small glimpse into what Wilma really is. I mean, Wilma is, when we say Wilma, we kind of mean all of the software that's behind the scenes that isn't the robot. So this particular video just shows you the interface, so the user interface. So this shows some scanning that SuperTom's done, shows you a heat map, and then it shows you literally down to the image level, and then highlights the, I can't see it now, but highlights the identification of crops and weeds, which is carried out by, through the use of AI. Basically, yeah, push all of the imagery through a piece of AI, and then it yeah, highlights what's a crop, what's a weed, if there's problems with the crop, any health issues, all that sort of things. So yeah, that's kind of the concept we're putting forward. I'm going to try and focus on Tom, because that's the sort of the key to the whole thing, is understanding what's out in the field first. Once you understand what's out there, you can then design your systems around the data that you gather. So I want to, yeah, we've seen that as the first stepping stone. So it's been the big focus for the work that we've been doing. Next slide. Oh, yeah. So the evolution of Tom. So as I've said, the Tom is a scanning robot. As you can see in this top image here, Tom started out as a very small robot, a small robot company, but this was a very small robot. It was kind of based around a remote control car kit, effectively, and it was a very useful tool for gathering data out in the field for things like autonomy and navigation, and helping us with the sort of the beginnings of geotagging and our imagery and that sort of things, which is a really important part of kind of allowing us to make decisions with the information once we gathered it. And then, as you can see, we moved on to SuperTom version 1. So we went to SuperTom because it was a step change in terms of what we could achieve out in the field. We could suddenly go from a coverage rate of sort of a proportion of a hectare with the small robot, the top robot, and then we were up to multiples of hectares with version 1, and then, as you can see, we then moved on to SuperTom version 3. So I'll go into a little bit more detail about first robot. So a very rough specification here. I must admit, there's a lot of the work that was done on this original Tom was carried out before I started at Small Robot Company. So when I asked people, "Oh, have we got a specification sheet for it?" it was quite hazy. But I've tried to pull together what I could and talk to some of my colleagues that have been there a little bit longer. So it was actually quite heavy for the size of it, 12 kilos. I was quite surprised when I asked one of my colleagues how much it weighed. Had a max forward speed, 0.4 meters a second. So some of the good points were, had a very low BOM cost. So we could buy them, work on them, iterate them. They were easy to transport. You could just put them in the boot of a car. You didn't have to worry about having a van or anything like that. They were, as I said, built on a from an off-the-shelf kit. So it meant that we only had to put the effort and the work into the elements that really added value to what we were doing. We didn't have to worry about sort of drive systems or anything like that. And it came with a sort of the bogie style suspension system as well. Video here, actually. So that was some of the good points. The bad points had a very low coverage rate, as you can see. I mean, you're not gonna hit off much of a field with a single robot in a day at that sort of speed. The perception from farmers was that it was a bit of a toy, and to be honest, they were kind of right. It was a very good way of setting ourselves up for the future and sort of showing that what we were about, but it was never going to give us a commercially viable coverage rate. It also struggled in longer crops because it had a very low ground clearance. And initially, as you can see on this robot, it didn't actually have a scanning capability, so we couldn't actually go and scan things. We did eventually create one with a single camera unit on it, and it was actually very useful and effective a couple of years ago. So we did use it to capture some imagery, but it was kind of useful amounts of data to kind of keep the AI side of things happy, but it wasn't what we call a commercial coverage rate. Supertom version 1, as I've said, went to Supertom. It was the super element. It was much larger. It had a massive 450 kilos. So some of the good sides about it. It was a serious improvement in terms of coverage rate. It had an improved perception from farmers and investors as a more serious piece of kit that could actually do what we were saying we could do, or we were going to be able to do. It was a really useful tool for testing and learning, not only from the sort of the software side, but also from the mechanical and some of the challenges we were going to see out in the field. And it also helped us with securing our following round of funding. So we needed to have something out there to say, we're no longer working with small toys, we're really serious about this, and we have some hardware that's gonna get us to be able to reach our goals. I've lost that screen. So some of the downsides, it was a very heavy machine. 450 kilos is quite a lot when we're on such small tires. The forward speed was a little bit better than that of the smaller robot, but the coverage rate still wasn't what we knew we needed. We were looking at about 1 hectare an hour. It was quite unreliable. I will caveat that with I arrived in July to Small Robot Company, and I was told when I arrived we needed to have something in the field by October. So this is what we were able to do in the time frame. It was a mad push, and we used whatever we could and made a lot of assumptions and decisions to kind of get us to that point where we had something in the field. We had a lot of issues with the drivetrain and the motors. We didn't have enough torque in the system, so we struggled a lot in heavier conditions in the field. So we've got a short video here of Supertom version 1 sort of ambling its way around. So we had to take the sort of what we call the boom, which is the large piece which sits out the front supporting the cameras. That had to actually come sort of partially apart. We had to disassemble it to actually get it into the van, which meant that deployment times were into sort of up to an hour by the time we got it into the field, done all the other software things we had to do, physically put the robot together, drop half the tools in the mud, pick them all up again, take some spares. So we knew we needed to kind of improve things from there, which is why we moved on to Supertom version 3. So much improved coverage rate, a much lower ground pressure. You can see there, ground pressure of 33 kPa and a mass under 250 kilos. We also had an increased forward speed and a much better understanding of our torque requirements. So we've never had a situation where we haven't had enough torque in the field, which we used to have all the time with the first robot. We also had a much better, or we made a conscious effort to really understand stabilization of the cameras and of the chassis, so that we could really improve our image capture capabilities. I will share the video. So this is probably the best video because this is proper marketing stuff, not not me stood out next to something. So this is Superton version 3 out in the field. It's just a much more competent and capable vehicle. So yeah, some of the downsides, it's not perfect. We still need 2 people to deploy that boom. We still need someone to hold one end whilst they unfold the other end. But we don't have to actually physically assemble it. It's all attached. We just reverse out of the van, unfold it. But the aim would be that we'd have a single person deployment, so we could we only have to have 1 person per robot to deploy the robot to set it off for a day's work. So it also had a relatively high BOM cost when compared to the previous 2 robots. And this design means that currently you can only fit 2 of them in a van. So our aim is obviously to try and fit as many as possible in a van, because that means we can go out and cover as many acres as part of our service as possible. So how do we develop Superton version 3? So this image here shows you a bit of a kind of a concept drawing for version 3, which we had. We worked with kind of an industrial design company based locally to us, and they kind of helped us we kind of explained to them a bit about how we thought the robot would be engineered, and then they used that to try and help set the kind of the look and the feel of the robot. So and this was really useful, because I think this helped remind us when we were working on the robot that this had to look like a project. It had to look like a product. It couldn't just look like another prototype out in the field. It had to look serious. It had to be a credible product. So this was actually, at the time, I was a bit kind of, being the sort of mechanical engineer, I was a bit skeptical. I thought, well, it'll look how it looks as long as it does the job. But actually, I think this really helped us to kind of keep things focused. So go to the next. So the first thing we did before we undertook the design of Superton version 3 was we carried out a bit of an appraisal of version 1. So we basically kind of got together as a team and said, right, what are the really sort of headline things that are causing us problems that mean that this robot version 1 isn't a credible product. And so it's all those things you kicked yourself on when you got the robot out after the big push of getting it built, and then thought to yourself, that's not quite worked out, that's not quite gone according to plan. So we wanted to make sure we learned from that. And so we kind of identified a number of key attributes. Some of them are listed there, which we kind of pulled together in a centralized spreadsheet. So we said, okay, we know we need to understand all of these things better to actually make sure this next robot's gonna work out in the field. And so some of those key attributes were wheel speed and wheel torque requirements, steering torque requirements, ground pressure, and some of the tyre characteristics. We needed to have a better understanding of the mass of the robot and a breakdown of the mass of the robot, and a better understanding of the kind of the cameras, so the resolution, the image patch, the number of cameras we needed, the height they needed to be at. We went basically pulled all that together in this centralized spreadsheet, which helped us to create models for all of those attributes. And then I'll go on to the next slide. So this is kind of loosely the process that we followed. We kind of took in our initial requirements. We knew there were certain business requirements we had that we kind of been working with some of our customers and some of the farmers. We've got the farmer advisory group, which we're able to draw on as a resource to ask questions, and basically the two founders I sort of showed you earlier on, they went and spoke to them and said, right, okay, what would a credible system in the field look like to you? So that was what's always been driving our sort of very high level requirements. So we took those requirements, but we also took the learnings from Superton version 1, and then we fed those into the spreadsheet, created models and simulations. Some of those weren't always in the spreadsheet, but it was really key for us to understand these characteristics a bit better. We knew we'd had problems with some of those elements, so we created models and simulations, and then we carried out validation testing to make sure that the models and the simulations were actually accurate and representative of what we thought they were. So sort of reassuring us of our assumptions, or replacing those assumptions where we needed to, and we kind of followed a bit of a loop until we were at a point where the models were solid enough for us to then move forwards to create subsystem component requirements and the specifications for those. So I've tried to kind of create this in a clear way. When you're in the thick of it, it all feels like a bit more of a mess than this, but out of it, looking back, this was the process that we followed. So I really tried to make sure that the team were all pulled together in one area, and that we really understood all of our failings from the previous design, so that we could improve the product. So if I go to this, so this is just an example of some of the calculations that we carried out. So this was actually done by one of the guys in the team, James Vining. He's another ex-Harper lad. He came to us from as a graduate, and so basically he'd done a large amount of work for his dissertation on traction. So he basically got tasked with, we need to know how much torque we need. And so he took everything that he already knew, he carried out some more research, and we built that up into a model. And then he carried out some testing there. So you can see that's actually the diagram at the bottom is a diagram of us conducting some pull tests with Superton version 1 to try and understand some of the behavior and characteristics, and try and use that as a starting point. It wasn't the only thing we used to feed back in, but one of the factors to feed back in to our models. So this sort of shows you our kind of looping process, where we were making models, making assumptions, and then proving them out, and then updating the models. And so yeah, this was a really big part about kind of what the approach we tried to take. So again, got another slide. So another thing we wanted to understand was steering torque. So we created this rig, which allowed us to look into a number of different things. So we were able to adjust the load. You can see there we've got some weights loaded up on the top of that rig. And then we were able to use a load cell to measure the steering torque. And we're able to do that for sort of a number of experiments. We're also able to change the different wheels and tires, so that we had a bit of a spread of information. And as we were moving along, we were kind of deciding on a tire, testing it, deciding we didn't like it, moving on to another thing. So we had quite a high churn of kind of test and validate, until we got to the point where we selected our tire. We worked with a consultancy to help us develop our steering actuators. So the steering actuator kind of sits inside the chassis, and is a motor and gearbox unit, which the rest of what I kind of call the leg unit. So there's a sort of anything below the chassis that has the wheels attached to it. So that anything that steers or drives kind of all constitutes part of the leg unit. The steering unit, basically, the steering unit is what the leg unit mounts to, so steering actuators. So we needed to do this testing quite quickly, because we needed to be feeding that information into the consultants as quickly as possible, so that we could give them peak torque requirements, and a number of other things that they needed to help them to kind of freeze the design as quickly as possible. So yeah, that's kind of how we went about determining what our steering torque was. So again, in a similar way, we looked into contact patch and tire deflection testing. So you can see there we had a number of different wheels and tire combinations that we were interested in understanding a bit better. So we used the same rig as the steering testing rig, but we repurposed it as a tire deflection rig. So you can see the diagram sort of bottom on the right. We were able to measure the center line of the wheel before and after loading, so we could understand deflection, which is shown in that graph. And then we had the contact patch area, which we were able to measure, so that was able to give us an understanding of the ground pressure. So all of this information we knew was really key, because it was all information we didn't have when we came to design Superton version 1. And it was all things that came back to bite us. So we made a really big effort to do this. And again, we took the information from this and fed it back into our models, so that we had a much more accurate understanding of what the robot was going to do when we came to actually build it. So again, we looked at, we changed tack slightly on the boom, as you can see. I mean, from the previous pictures, we've gone for a carbon fiber style, or carbon fiber, single tube of carbon fiber. The idea behind that being that it was very stiff and very light, but we didn't make that decision without proving it to ourselves first, validating our numbers. So initially, we just carried out some hand calculations based on the data sheet that was provided by the manufacturer. Made sure that we were happy with that. We also carried out some finite element analysis to understand the deflection, see if that lined up with our initial calculations, and then we also carried out some testing. So again, this is one of my colleagues, Andrew. This was actually during sort of in the depths of lockdown. This was actually in his garden, not a SRC HQ or anything like that. So as you can see, it was a bit of a ramshackle rig, but what it did prove was that we were going to get the behaviour that we thought we were going to get. It kind of comes with a bit of experience that you have to take. Sometimes you have to take a specification sheet with a little bit of a pinch of salt, and it's nice to be able to prove it to yourself, especially with something like this. I mean, we're talking maybe £30 for the stretch of carbon fiber, and a day's worth of testing, and all of a sudden we've got a whole load more confidence in some of the assumptions that we're making. So mass breakdown. So the target with the version 1 robot was optimistically 100 kilos for the weight of the robot. As I said earlier on, it was 450 kilos. So we massively overshot that, and I think we learned from that the hard way. It had a massive impact on the drivetrain, had a massive impact on the ground pressure, and so we knew we had to get a better understanding as the design matured of where the mass was, where we were picking up mass, and then finding out the sort of the low-hanging fruit within the system to try and pull that out wherever we could. So this pie chart was invaluable because it gave us an understanding that the drive system is one of the biggest constituents of the mass of the whole robot, and then we're able to go through that and make. So you can't always pull mass out just by saying we want to pull it out, but there might be elements in there where we were able to swap around. So we changed for lighter motors, and we made all sorts of different decisions. I mean, we were constantly, I don't think we were quite F1, but we kind of had that mentality of just trying to pull mass out wherever we could. We also were able to mature this mass breakdown once we started working with our with Randall Engineering, who are a ride modeling kind of and suspension specialist. So we went in with the, as you can see there, 50-50. We went in with the aim of having a 50-50 mass distribution on the robot. We didn't actually hit that, but we had at least had an understanding of what we did hit. So we were able to understand if there was more, if there was a higher ground pressure on the front tires when the boom was deployed, and also what impact that would have on the steering torque requirements as well. So again, that testing that we did on the steering was invaluable because we were able to work back from that testing and say, oh, we're still in specification of the steering motors, so we're okay, or we need to move some mass around to kind of keep us within the operational envelope of those steering actuators. So this was really useful. It became one of those things that we were just reviewing it every single day, seeing where we'd managed to pull mass out, and just became one of those constantly changing things. So as I touched on, ride modeling and stabilization. We had a suspension system on version 1, but it was a bit of a guess. We picked some spring and damper units. We picked a motion ratio, and we tried to make it as adjustable as we could, and then we went for it. And it actually performed relatively well, considering it wasn't really engineered. I would say it was just kind of designed, but we knew we wanted to do better than that, and so we worked heavily with a company called Randall Engineering, and so we went out into the field on again, James went out into the field on a very rainy day, which he complained about quite a lot afterwards, but he spent all day out in the rain with a tape measure, measuring the terrain that we were going to see in the field. We took various cross sections across the field. I think we went sort of 90 degrees to kind of the drilling lines. We also did sort of 45 degrees, and we kind of looked at the macro level and also the micro level. So we also looked at individual tractor ruts in the tram lines, and also looked at sort of representative stones and lumps and bumps within the field. We gave this information to Randall, and then they basically turned that into a kind of a standardized ground profile, which they were able to kind of, I'm not 100% sure exactly what they did, but they were able to create a model from that, which they could then extrapolate forwards to be a much longer ground profile, which then they could look at the ride modeling and use that to help them, along with our mass tracker. They use that to give us an understanding of the kind of the hard points for the suspension design. So the motion ratio, where we needed to have the suspension strut relative to the wheels. And they also helped us to understand the damping characteristics we needed, and the spring characteristics. We also kind of took a slightly novel approach with the boom. So as you can kind of see in the model there, we had the boom is separately, it's kind of almost like a seesaw, but with a damper in it. So it's able to kind of move with the contours of the field to try and, as best we could, kind of with a passive system, work our way across the field, and kind of maintain the cameras within their focal limits, which actually it looks quite ungainly in the field, but when you look at the imagery that comes back, it actually works very well. So I was really quite pleased with that. And then I've got Quantum Racing Services there, so they are the supplier for our for the spring and damper units, and we worked very closely with them, and we kind of, the three of us, Randall, ourselves, and Quantum, kind of got together And there's a few meetings where we kind of hammered out what it was we needed, what behavior it was we needed, and then Quantum were able to tune the spring and dampers to our requirements, and then they carry out a validation where they have a spring and damper dyno rig where they basically put them through their paces and ensure that the behavior we thought we were going to get is what we're actually getting. So that was really, really useful, really, really helpful. They were two companies that were actually really, sometimes you get nightmare companies, but these guys were really, really good, really nice companies to work with. They're quite relatively small, really friendly guys, really helpful. So yeah, that was actually, I really quite enjoyed just kind of learning more about that stuff. It's not something I've had that much involvement with before. And last thing, they helped, so Randall helped us with a multi-body simulation, which they kind of call an Adams model, which is the image you can see of the kind of representation of the robot there, which helped us to understand our load cases, and ultimately we were able to understand the loading on each of those different colored joints, which we could then apply using finite element analysis to actually understand the behavior of the parts that we'd modeled relative to those loads. So that was, again, really useful for us to be able to move. I mean, we spent the money in this area, but it meant that we could move forwards with a very small team and move forwards really, really quickly. Yeah, that was really quite a core piece of this, but really kind of set this whole robot apart from the Supertom version 1 in terms of kind of capabilities. So I thought I'd touch a little bit on the kind of chassis and the manufacture of the chassis. Again, from our learnings and from the mass breakdown, we knew we needed to have as lightweight a chassis as possible, but we didn't want to go down the route of bespoke tooling and looking at kind of carbon fiber manufacturing or anything like that, because the tooling costs would have been very large and the lead times would have just eaten into us actually getting out into the field when we needed to. So we kind of went for a bit of a balance. So we wanted to use manufacturing processes that were accessible and relatively quick to turn around. So you can see there we had and there's sort of, so top image is basically Supertom, but with no body work on. So you can kind of see the chassis there, and then on the right hand side is the chassis before it was jigged up and glued and all the rest of it. So that was just a layup. We had those parts to hand, so we just wanted to sort of lay it up. And the approach we went for was 4 machine pieces, which you can see in the lower image there, as the kind of the main mounting points. That was the areas where from the FEA studies we saw we were getting a lot of the stresses. And then around that was a folded aluminium structure that was bonded and riveted and then painted or powder coated. And this actually it worked really well. We had basically Randall had a kind of rule of thumb when they said it comes to chassis stiffness, we needed at least 5 times the rollover stiffness. And so our target was 325 Newton meters per degree, and we achieved 2,300 Newton meters per degree. So it was a really stiff chassis. It was kind of akin to like an airframe where we had sort of machined elements, and then we had some really quite thin pieces of aluminium, but because we were stressing them in the right ways, they kind of delivered the results that we needed. And it was, I think, from that mass breakdown, the chassis isn't one of the larger elements of the whole robot's system in terms of mass. So I think we actually did pretty well there. And we did actually spin a project up for a student last year based around some of our investigations into this type of manufacturing. So that was quite good as well. So manufacturing. So we worked with a third-party company called Tharsis, who are based up in Blythe, which is just outside Newcastle. They are really quite a big manufacturing firm, and they have they've worked. One of the key companies they work with is Ocado for all of their. They've got like robots that run around inside packing houses, moving products to and fro on kind of a grid rail sort of system, and that was one of their really big that's one of their really big customers. But I mean, they do work for all sorts of people, and they're really focusing themselves around sort of I can't remember the term they use, but basically robots. And so we basically had a manufacturing cell at their site, and we had access to their technicians and some of their engineering teams and their sort of development team. And so we were able to use their, supply chain as well. So most of these parts, sort of 98% of these parts, were procured through Tharsis and through their existing supply chain, which was quite good. They've obviously got a lot of kind of bargaining power with some of their supply chain because they put so much work through them. So we were able to kind of piggyback on that a little bit, and also learn from some of their approaches. So they designed the jigs and the tooling that we used to set the chassis out before we bonded it. You see one of the jigs there in the background on the sort of the larger of the right hand, the bottom there. And yeah, it was a really interesting experience for sort of myself, and there's me and James up there. I'll play that little video actually. So it's just us cracking on with stuff basically. Really interesting experience for us. I mean, I've worked in sort of factory environments and things like that before, but it's quite the Tharsis approach is quite different to sort of how we approach things. So it was good. It kind of pulled us, made us pull our socks up a little bit in terms of making sure we had a bill of materials up together, and a drawing pack up together, and getting that out to them so that they could actually procure the parts and get them in on time. It was a little bit frustrating at times because we're kind of used to just getting on the phone to suppliers and that sort of thing. So, yeah, we pulled the robots together, got both of them built and down to ourselves. And I think we did that in, I think it was in sort of it was in about 3 months. We had a few hold-ups on the electronics, but sort of in start to finish, I think it was 3 months to get those built, which to be honest, for 2 of them, with a lot of the electronics being sort of decided on the fly, actually was pretty good going. So finally, the team. So this is my my current team, all but one of them. I'm not sure where he was. So basically, one of the biggest things I took away from the version 3 kind of development, design and development process was how much having a team working on something improves it. I mean, when I arrived and I was working, I was pretty much solely responsible for the mechanical engineering of version 1, and I did it pretty much on my own. I had some help from a few people, a few placement students, but it was a lot of work in not a lot of time, and I think it really showed how much better version 3 was when we suddenly had 3 of us working on it, and we were able to swap ideas, critique ideas, question things, make decisions as well, and also help to build up the models and do the validation testing that on my own I couldn't have done. And I think that's really I don't know, for me, that was probably one of my biggest learnings, was just looking back, and you look at that robot and you see how much better it is, and you know that's because of the involvement of the team. So there's, at the moment, there's seven of us in my team, including myself. And so while I've been growing the team, I've always been kind of looking for people who are keen and excited to get involved in what we're doing, and kind of either some people are really keen on robots, and some people are really keen on the agricultural side of things, but really finding people that are enthusiastic, but that are happy to question kind of how and why we do things, because that really helps us to make sure that we're constantly reviewing our procedures and our approach to make sure that it's as good as it can be. So I think I'm right in saying we've got a pretty open team within the mechanical team, and if someone doesn't like something, they'll just say, I'm not happy with this, I think we need to change something, or can we improve this, or I've had an idea, and that's really powerful in sort of helping us to improve our products and services. And that is that. So yeah, thank you very much. If anyone's got any questions, fire away. Yeah.
What's the vision for these robots, in the sense that, are you looking to replace what I would call, traditional agriculture with big diesel engines, or are you looking at this to be a sort of an addition to it, so you could use alongside? What's the sort of vision for
So I think at the moment with.
Can you just repeat the questions that people online can hear?
Yes, yeah. So just asking what the vision is for the robots. Are they intended to replace the traditional agriculture, or are they intended to work alongside? The way I see it is, it's going to be an evolution, and we need to be able to work alongside, and we are working alongside agriculture right now. So we're out in traditionally farmed fields. So we've got tram lines. The crop's been established using a tractor. It's going to be harvested using a combine. At the moment, it's going to be chemicals are going to be applied using a sprayer. I think our approach will will naturally become part of an addition, and then it will probably become a progression. So I think it will be an evolution. I don't think we could overnight just turn up with a suite of robots and say, right, okay, all that equipment in your shed, just get rid of it. I think we need to be working alongside farmers, and we are. And I think the Tom service, the scanning, will be where you'll see the biggest gains in terms of being able to make decisions out in the field, and being able to have the that next level of understanding that you don't get from a quick crop walk, and sort of saying, oh yeah, it looks a bit, I'm not sure, or you've got a bit of this or a bit of that. All of a sudden, you've got a complete understanding of your field at the really minute level. So that means that you can then move forwards to look at sort of really precise management of weeds, really precise management of sort of pests, and other pressures on the crops. That's kind of how I see it. Obviously, the founders are sort of, we're going to go big, and I think we are, but I think we'll be working alongside sort of traditional agriculture for quite a while.
What's the timeline on commercial service scanning then? Because I've heard mixed.
So yeah. So the time. So
how widespread is it going to be?
So the timeline on the commercial service, we're sort of looking at. So we are actually delivering your commercial service now. So we've been even today we've been out in fields. We've got 2 robots, which are the 2 that you can see there, and they're out actually doing paid work. Obviously, we're a startup, we're sort of investment funded, so we're not about to be able to just say, right, okay, let's put 50 robots out there, but the aim is we're proving these through what we're calling service iteration 2, which is us sort of saying this is the service and how it looks right now. We've got aims of the service, you know, shooting for the moon. Next year is basically where we're sort of saying we want to be ramping up to a point where we've got larger numbers of farmers towards the end of next year, when they're going to start, when the weeding service is kind of makes sense for them to go out and do. So kind of look around October time when we start heading out. We are sort of looking at other potential customers for this, but I can't really go into that. But for farmers, it's looking towards the end of next year to be expanding out, but it's all obviously dependent. We can have a plan, but we've also got to have the sales to back it up. So I kind of know the plan, but we need to make sure we're going to get the sales in to actually do that.
But what's the vision? Sorry to labour the point, but what's the vision for the future about getting coverage across the country, or not just locally to HQ or whatever? Is there a plan for that, or just trying to see how it goes?
Yes, yeah, no, there is. So we're looking at an approach where we kind of have the idea being that we can get out into the field a bit more quickly and to cover more farmers, because basically the problem we've found is that a lot of farmers will say, yes, I'm really keen on your system, but I only really want you to come and have a look at 20 hectares at the moment, so I don't want to fully commit to all the investment that would be required and handing over some control of what I do for the whole farm. And I think this is something I've personally seen in sort of previous roles, where there's always that looking over the hedge and what are they up to, and you don't want to be the person that gets egg on your face that goes, oh well, he's trying those robots out and it really went completely wrong. People always want to try out a small area, so the idea would be that we can get out into more areas in the country by basically having probably sort of a centralized robot or handful of robots that are able to go out to a local area to say, right, I'm going to go out and do your 20 hectares that you're really keen to look at, and I'll do yours and I'll do yours. Once we're out there, I think it will grow quite quickly, because I think they'll see the power and the value of that 20 hectares. All of a sudden they're like, wow, I can do, there's so many things I can do, and there's so many decisions I can make that I can't make on the rest of my fields. And all of a sudden you'll see it sort of start to hit that curve of people kind of taking it up and moving forwards.
Is this something that you'll like consider franchising out? I don't know, so Harper Adams graduates, or is this something that's always been internal service?
At the moment, it's because of the maturity of the technology. We always go out with someone from small robot company, but the vision wouldn't be that we would be doing that forever, because I mean, the economics don't necessarily make sense when you've got to have a person to go and stand next to a robot. You're almost better off with that person doing that role. So in the longer run, we'd be looking to mature the technology, which we're kind of working on the safety side of things in the background, and kind of getting that to a point where we can have robots out sort of being autonomous and sort of doing that, and then we can kind of then we can move to a point where you might be looking at more of almost like a subscription model, where you're just you pay perhaps an amount of money per robot, and then you pay to have that robot updated and maintained and continued. And then you might reach a point at which we've got the next robot. So if you pay a little bit more money, it's kind of similar to buying a phone on a contract. You might pay £200 for the phone, and then you might pay £30 a month, something like that. So that's what I've been told. That's kind of slightly outside of my sort of day-to-day stuff, but I've kind of got a bit of a knowledge of it. So
could you explain a little bit about the vision system and how that integrates with the AI, and is it looking for disease or weeds or everything? Does it do everything that a agronomist can or more?
I think the intention, so it's a question about the vision system and how it integrates with the AI. And what we're looking for, does it line up with what we could an agronomist would be looking for? So answer to that would be, it's once you've got the imagery, you can push it through whatever system you want in terms of AI. And AI is one of these things. It's quite. I still don't know that much about it, but it's ultimately, it kind of comes down to you're as good as your markups. So literally, people marking up imagery, that's pretty much how most AI works at the moment. So you give it an image that you've trained to say, this is a weed, this is a thing, this is whatever. We're looking primarily at the moment at weeds, but we do have work going on in the background to then be looking at other things, diseases and pests in the crop. So yes, ultimately, you would be in a position to be looking at more than just weeds.
So is that what it currently does, just weeds?
At the moment, yeah. So that's.
Is that all weeds, like blackgrass, with that weeds are significantly different from being
We are working on blackgrass. Blackgrass is really tricky to see with, so we've got RGB cameras and it's really tricky to see with those. We're working on our next iteration of imagery, and I'm quite a big part of that, because quite a lot of it is kind of how high you set the cameras off the floor, where you set them relative to the robot, the behavior of that side of things, the kind of the mechanical elements of the number of pixels per meter squared, etc. So we're working on that, and we've worked with a few other companies to develop some systems that can find blackgrass, but we haven't on these existing robots as you see them right now. They don't have that capability. It's predominantly broadleaf weeds. John.
Right, yeah. If you wouldn't mind answering, you've designed the entire system around it running on standard batteries at the moment, but is there battery units, do they come out or do they charge inside themselves to actually allow you to get long periods of time operating out into the field instead of just their standard 4 hours that you stated?
Yeah, so John's question. John's question was around the batteries. Are they removable? Can they be charged on the robot? Can they be replaced to extend running times? Is that right? Yeah. So the batteries are removable. They're kind of, there's 3 of them in Supertom at the moment, and they're sort of roughly the size of a briefcase, each with a handle on it. They're just sort of strapped in to maintain their position so they don't roll around, fall out or anything like that. So you can undo the strap, pull the 3 batteries out, take them back to the van, and then swap them out for another 3. So 4 hours runtime is 8 hours runtime as long as you've got someone to swap the batteries. We're working on extending our running times, and we're basically not a million miles away from kind of doubling it basically. But there's some hardware changes we need to make, and we can't make those on this existing platform. So at the moment, we're for these 2 robots, we're at 4 hours and then a swap, and then they're charged off the robot, so they each have sort of individual chargers. So we basically just take them back to base, and then we just go out with a van full of 2 robots and enough batteries to run the service for the planned day's work, and then just swap them out when they run low. Yes.
So as meeting you mentioned with Dick and Harry as well.
Mm-hmm.
Are they very much in the future? Is there much design work on them at the moment happening? And then as well as that, with it, how close to commercial viability you are? Are you several iterations away, or are you pretty much almost where you want to be?
Yeah. Okay. So the question was around Dick and Harry, and whether we're working on those, and then how far off we are from them being commercial. So we've been working on the function of the Dick robots, the weeding robots, for pretty much the whole time that I've been at Small Robot Company. So we've done a number of Innovate UK funded pieces of research, basically looking at how we can go out into the field and effectively precisely point at a weed. Once you can do that, you can choose what methodology you want to use to control that weed. Whether we've worked with, so we did some work with a company called Rootwave, which was looking at zapping weeds. We're also not writing off the potential to do sort of small, use very sort of small controlled spray area to control the weeds as well. In terms of the development work that we're doing, we're working on kind of, in the background, we've been working on a robot, kind of more like a platform, so that we can test things really, really quickly. But it's a bit more than the one that you might have seen. I expect everyone, if you know anything about us, you will have seen that one that looks kind of like a big spider. It looks a little bit ungainly, and some of the engineers that I work with are really, you know, they're quite defensive of it. But I think it looks a bit, yeah, it's very striking, and it really captures people. Whenever you say, "Oh, small robot company," everyone always says, "Oh, you've got the massive robot spider," and you're like, "Oh, yeah." But so we've been working on that, but we're working on a platform where we can swap elements in and out really quickly. To do that, we went around things again. So we did exactly what I said before, and took all the learnings we had from version 3. It's by no means perfect, and it never will be. We tried to apply that to our platform, which we will be then using to deliver the weeding service, and some of the other research projects we've been working on in the background will find their way very rapidly onto that. We've built a prototype for that platform. I can't sort of show anyone anything at the moment, but I mean, we're looking at trialing that service next year in a kind of a commercial trials, not just or weed it out and see how it goes, but actually send it out. So I hope does that answer that? Perfect. Yeah.
By mentioning your platform,
Mm-hmm.
you therefore intend to convert or merge all these 3 robots into 1 or 2 machines with potentially interchangeable heads or booms?
Yeah. So the question was about kind of it being the robot being a platform and then having sort of interchangeable functions. We're kind of looking at that approach. I think that makes the most sense. I've always, and it's obviously there's always different opinions on how we kind of get robots and ultimately functions out into the field. I always think of Tom, Dick, and Harry ultimately as functions. So they're not necessarily a robot, but they might have to be a robot if there isn't enough overlap with some of the other functions that they have to perform. I mean, that video I showed at the start kind of showed you one approach that we were thinking about, which was basically saying, "Oh, well, we'll keep the leg units the same, and we'll just add additional leg units in different layouts to effectively use a modular approach to laying out some sort of standard small robot company equipment," if you know what I mean. So we'll just say, right, okay, we need a Harry, we need to have 6 wheels rather than 4 because it's a heavier robot. I wouldn't write that off completely. I think at the moment our real focus has been on Tom, and then trying to rapidly develop the weeding side of things, and then the platform. So Harry, in my mind, is just that little bit off in the distance, and I think it should be really. I think we need to be focusing on kind of, as I've said, like working alongside farmers and what they're doing right now, and really adding the value. And there's loads of value just to be realised from the scanning service without having to even do much more than that. But you stand on a trade stand, and someone always says, "Okay, you can show me some really good imagery of a field. What can I do about it?" So there is the logical next leap, and that's why we've been pushing in that direction. So I don't know if that helps. Perfect.
I'm sorry, also on that, in terms of providing a service, do you see this entirely as you owning and taking the machines to places, or do you see potentially a machine in sort of area and the farmers will work them up or have them on their farm for use by themselves?
Yeah, so the question was around how we see the service and whether we see it as purely a service we go out and deliver, or whether we are sort of having farmers being able to access the hardware. Is that sort of roughly right?
Yes.
Yeah. So the approach we've always taken up until now, and what we've always been saying is farming as a service, which is the service that's delivered by us, and we take that robot out from the van. We are looking at trying to sort of make it so it's a little bit more accessible to the farmer, and it's down to the hardware. Basically, farmers having access to hardware in an area, and it might be that you have, say, 10 farms altogether that have access to an amount of hardware. As I kind of said, initially we would have that hardware being supported by a technician or an engineer from small robot company to help with the kind of help with the delivery if there are any technical issues, if there's any sort of risk assessments or anything that need to be done before we head out. They can undertake that, so that kind of helps us to step towards like a fully autonomous system, which is obviously the goal, but we have to work our way up to that. And I think most companies that are in the sort of similar position to us are kind of finding that too, that you have to make those steps. You can't just leap straight in with, oh, we're fully autonomous and off we go. You have to kind of step up to it. So I hope that answers that question. Yeah.
Right. You said that small robot's been going around for 4 years. You've
Yes.
been there around 2 years.
Yes.
Paraphrasing somewhat.
Mm-hmm.
And clearly, the mechanical machines have developed a huge amount in the 2 years you've been there, compared to maybe the more visionary people who were there at the start, with the less sort of engineering capability that you brought to the table, and then the team which you built. So I guess my point is not just saying you're amazing. You are. For a room of essentially student engineers, what do you look for when you're growing your team? What do you look for when you're interviewing for new engineers to join your team to basically turn a rodeo control car into an actual product?
Okay, so yeah, the question was what do I look for in when I've been building my team? What have I been looking for in sort of candidates? I think the key thing for me is enthusiasm. So it's really enthusiasm, sort of something you can't teach someone if they're not enthused by what you're doing and kind of the challenges that you've got to face. You can't teach them that, but you can teach people how to do a technical drawing, or how to complete all of the work that I've talked us through. I mean, we've taught each other some of that. I've taught some of the guys in the team that. I mean, so when James joined with us, he had a good engineering knowledge, and so he as a graduate, but we taught him a lot. But the key thing that he had was enthusiasm, and he was very, very persistent. So he kept basically just kept badgering us and said, I'm really, really keen. I'm really, really keen to. We interviewed him, and it was pretty obvious we needed to take him on. Other than that, it's just a willingness to ask questions and say, are we doing this in the right way? Is there another approach? I think we've got quite a good team in terms of the way in which people think. Not everyone thinks in exactly the same way, which is really good for us, because it means when we're approaching problems, you don't just get 7 of the same solution, you get 7 slightly different solutions, which is really useful. And even when we've been working on prototypes, and some of the electrical guys are asking quite probing questions about the mechanics, and I think that's really good, actually, because they could just sit there and go, well, it's not my problem, I'm not really interested, but they say, right, oh, what about this, and or have you thought about that? And so even if it means that you just have to justify it, it means that you've gone through those steps and gone, oh, actually, you've got a point there, yeah, well, you better have a think about that. and then you can come back and say, oh, we've justified it now, we're really sure, you know, or we did do a piece of work on that, didn't we? Yes. So it's yeah, enthusiasm and like a willingness to ask questions and a willingness to learn. So I've been yeah, we recently took on a placement student, and he's just been constant stream of questions, which has been quite intense for me, but really, really good, because he's just absorbing information all the time. And so every day you get to the end of the day, he's that little bit better. And I mean, we're already giving him stuff that you know, he's learned a lot already in terms of his capabilities and understanding of sort of engineering. So does that answer the question?
Yeah, no, I mean, some of the stuff you were doing there was really Harper Adams-y stuff in terms of like terra mechanics and that sort of thing.
Yeah.
So in terms of this group of people, they were useful skills to you.
Yes. Yeah.
Those Harper Adams engineering skills would be useful to you and your team.
Yeah. So the Harper Adams skills were invaluable, and that's what James brought. And he brought those skills in terms of, I mean, we were quite lucky. He did his dissertation, and it was, I don't know exactly what it was, but it's something to do with terra mechanics. So he basically said, guys, kind of, I've got this. Obviously, it wasn't just, he didn't just go off on his own, but we kind of worked through it with him. But yeah, those skills were really, really useful, and kind of being able to hit the ground running in terms of, he already had a knowledge of engineering drawings because he'd done a placement and he already produced them. So when he came, it was only a few tweaks to things rather than a complete, this is a drawing, this is how you do a drawing. So that was massively useful for us, especially when he arrived, and we basically just had to get going as quickly as possible to get onto the next robot design. So he's brought those skills, and Sam's the same, and I hope I'm the same to some degree as well. So yeah, very useful. Yeah.
Subject of question before being awkward, not on the same subject, but so playing devil's advocate, what if you talk about these things as systems or functions? Sorry, not robots. What happens if someone says, I've just bought a 40-meter horse sprayer, I want all of these sensors on that? If you get to that point when technology can work at faster speeds or something, are you going to discount that because that's a large-scale machine and you've been working with technology that goes on robots? Or I'm not saying you want to be a retrofit manufacturer, but
yeah, I mean,
large scale completely off limits just because? Or?
So yeah, so the question is a large scale approach off limits for a small robot company? I think the big drive is, and has been to try and, you know, ultimately we're working alongside farmers, but we're kind of coming in from that approach of trying to be kind of low impact on the field and trying not to cause compaction and that side of things. I think with everything that we're doing, we're kind of creating a system that is lighter on the ground. I mean, we're now able to prove that because of some of the work that we've done to say, you know, our ground pressure is lower than you'd see for a tractor. I think there's a few key benefits to what we're doing here with Superton that would make an approach perhaps on a sprayer not make so much sense. In terms of, on a sprayer, you can go on a day and do some spraying, probably with some scanning. But if you sent a small robot over the ground that doesn't do any damage, and it means that you can make a decision before you even get out of bed in the morning as to how much you want to put in that sprayer and how much chemical you want to use, where you're going to go, all of a sudden you've not just saved chemicals, but you've saved a lot of operator time, fuel. So I think that's where you'll probably see, you know, you could say, well, I now know where I need to go and spray. I don't need to go and spray here, or I can make a prediction based on, you know, this is kind of what I'm saying. As soon as you get that imagery in and you can start making decisions on it, it's really, really quickly for us to iterate that through our software approach for the Wilmer interface to say, okay, if you want to go spraying today, this field needs, you know, our approximation would be you need this much chemical, you know, prevents you having to dump a load because you've ended up with a load left at the end of the day. or trying to sort of eke it out around somewhere else. So it allows you to be that little bit more intelligent than just fill a sprayer up and then spray a few key spots. But yeah, I mean, you're right. There could be some overlaps, and I suppose I'm kind of don't steer the business case, but you could make an argument and say, well, why don't we piggyback in that way and leverage some of our technology? And I suppose I would say, from my perspective, never say never, but I would say it kind of comes down to the vision of the founders as well, to say the way in which they want it to go. And I think the way that they're keen for it to go is ultimately towards reducing the size and of the machinery and the impact that it has on the soil.
No, thanks. It's just been awkward, to be honest.
Yeah, that's fine. No, there you go. You got the job.
Yeah.
Sorry, Ray, you just inspired me for another question.
Yeah, okay. Yeah, that's cool.
Is the approach for the operation of these vehicles to literally scan every square centimetre of that field, or if you use some kind of intelligent service such as satellite data or drone imagery to literally then go to zones in the first place, do you literally try and then target the most appropriate areas to then get the most data or the most useful area from it instead of just covering the entire area?
So, question being, how is our approach just to scan the entire field, or is it to try and be selective with our scanning based on imagery from satellites or drones to preempt a route or a path? Is that sort of kind of trying to paraphrase? Yeah. So the current approach is we're coming from this per plant farming, so we are saying we will scan the whole field. So you have a really detailed understanding of the field. You also have all of the images are geolocated, so if you want to return to a weed or a crop plant and make a decision about what you want to do with that, you can go and do that. I think if you had some sort of higher level imagery, I think you could probably create a hybrid between the two, but I think the real push for what we're doing is being able to make decisions at that plant level. So I think as it stands, I think we need to be scanning the whole field to provide that. But yeah, I mean, again, never say never. If drones did make sense to come in, come and work alongside, then I don't think we would just write it off out of hand. But I know you love drones, John. So
Where does Wilmer stand on output to the farmer or the agronomist, and where does that stand on the basis of facts, and how you interpret that in its use? So does it give out a map that you can then use with coverage spray on your horse spray, for example, or turn on the 6 metre sections where it knows our patterns all the weeds, or is it only then the agronomist got to then interpret the pictures and you have to verify? So how are you confident in what the left is going?
Yeah, okay. So the question is, what are the outputs of Wilmer, and how does that integrate with the approach of the farmer right now? Yeah. So again, on that, it was not the best video, but it's sort of the best demo video we've got of how you work your way through from the very top level of Wilmer and down through the layers until you get to the point where you're literally looking at a single image. What it will give you on the way down is a heat map, and you can, because we're geolocated, in theory, you could say you could integrate with an existing system where you can shut off nozzles to spray specific areas. The information, because of the fact that we've got that geolocation, you could then say, kind of what I was talking about a bit earlier, you could say, right, okay, we've got weeds in this area, weeds in this area, weeds in this area, let's just go out and get those ones. And then we don't have it right now, but it wouldn't be you know, it wouldn't be too much work basically for us to say, right, okay, you've got this spray, you need this much chemical, you need to go in these areas. So yeah, in theory, you could upload it in some format to a sprayer and say, right, okay, I'm going to go in these particular areas, I'm going to spray these particular patches, which I see as quite a good way of again working alongside farmers rather than saying, oh, you need to change everything that you're ever doing. You could say, well, you can evolve what you're doing and use our technology to help you make better decisions with what you've got right now. So no, we don't. Yeah, so they do get an identification of what weeds are in the field, and they do get an identification of where they are within the field. As I've said, we're kind of at the broadleaf weed stage at the moment, and then looking to go towards grass type weeds as quickly as we can. So that's what they get right now, but it wouldn't be a massive stretch for us to add functionality. I think that's the key behind the software, is that it is easy and quick to iterate. Yeah.
Right. You mentioned collaborating with a couple of companies, or 3 companies you mentioned that you collaborated with very successfully. On the sort of opposite end, have there been collaborations that have led you up the garden path, as it were, that have not worked out so well?
Yeah, so the question's around, have we had any collaborations that haven't worked out so well?
I'm a big fan of collaboration.
Yeah, no. I think from every collaboration we've had, we've learned a lot, and I think we learned a lot working with Randall, and that was an enjoyable experience as well. Those guys really know their stuff, and that was really just generally interesting as well from an engineering perspective, as well as Quantum, the suspension suppliers. We learned a lot working with Tharsis, and I think that was a big eye opener for myself and definitely the rest of the team. I think we made different decisions moving forwards for production of some other stuff, and some other prototypes, but I don't think we'd ever write off working with them again, because I think there's a lot of value to be had there. Certainly working with those guys at the right stages. As I say, it was really valuable working with them. Occasionally a bit frustrating, because it kind of felt, as the tech team, some of it was taken out of your hands slightly, but what it made you do was make sure you really understood the information that they needed to pull the product together, somewhere remote as well. So you can't just walk 2 minutes down the road and say, oh, how are you getting on with those bits? You have to be prepared. And I think that really forced us to do that, and just opened our eyes to what they're capable as well, and capable of as well, in terms of being able to, in the longer run, maybe help us leverage and build products quickly. So I think they've all been pretty positive. The collaborations that we have with CNC manufacturers seem to just be an absolute nightmare, and I don't know why, but it's just because they're always late on everything. I don't think I've ever had parts manufactured by a CNC company that have turned up on time, which is just frustrating, but that just seems to be how it is. Our best supplier at the moment delivers things 2 weeks late. So, but we're a comparative minnow, so they're getting monster orders coming through, whereas we're putting in through small prototype batch orders. So they're always there's going to be other companies out there that can trump you in the queue. So.
Okay, right. Well, I think we better perhaps call the meeting to a close now, and say thank you very much, Ray, for your time and your presentation and educating us all. So thank you very much.